In our final video for Unit 1, we're going to take a look at exponents and logs. And one of the things you have to know, or one of the things you have to be really familiar with, is what the relationship between exponents and logs are. If you were to have something y equals, say, a base b to the x power, we can rewrite that in terms of logs as the log base b of y equals x. The real strength in logs is that we're solving for an exponential variable where we have a variable that it's in the exponent, not in the base. In this class, we almost exclusively use ln, base e, instead of base b, but all the rules are the same for that as well. So just know that we use ln quite a bit. First of all, let's talk about some of the properties of our exponents. With exponents, we should know that if you have something like x to the r power times x to the s power, that we add those powers. It's just x to the r plus s. If you divide them, if you have x to the r divided by x to the s, it's x to the r numerator minus denominator. If you raise a power to the power, so you have x to the r to the s power, you multiply, so it's x to the rs. And if you have something like a product like xy raised to the r power, you can do them individually, so you have x to the r and y to the r. And you can do that same thing for a quotient, so you can write it as x over y raised to the r is x to the r and y to the r. Those are just basic properties of exponents. In terms of logs, a couple of properties you should know about logs. I'm going to do these all in terms of ln instead of in terms of log. The natural log of 1 is 0, and the reason for that is because e to the 0 power is 1. Remember, the ln is base e. The ln of e is 1. The ln of e raised to any power, say y, is just y. And if you were to have something in the format of e to the ln of x, that's just x. One of the things you will find that you need to be able to use your calculator for is our change of base. Later on in the course, when we're solving some exponential equations, we'll have to use this formula. The change of base formula is that if you were to have something like, I'll use log, if you were to have something like the log base b of x, and I wanted to evaluate that in my calculator, the way you would put it in is the log of x divided by the log of b. Furthermore, some properties of logs, some things that you're going to have to be able to work with. So if we have something like a product like ln of r times s, I can rewrite that as the ln of r plus the ln of s individually. Remember, we can't take the log of a negative number, so a lot of times you'll see absolute value symbols around that. It's not. I'll never beat you up about the absolute value symbols, but they should be there, and you'll see me write them most of the time. The ln of r divided by s, you can rewrite as the ln of r minus the ln of s. And then the real power is when you have something like the ln of r raised to the nth power, we can rewrite that as n times the ln of r. Really, this is going to be helpful when we go to take derivatives. The derivative ln is pretty easy to do, and when you have things like y equals the ln of, say, the square root of x plus 2, if you were to take the derivative of that without simplifying it, it'd be a real pain in the butt. But if you simplify it and write it as the ln of x plus 2 to the 1/2 power, and then bring that fractional exponent out front, you can rewrite it as y equals 1/2 ln of x plus 2, and then that derivative would be a lot easier to find. Let's take a look at a log equation, because sometimes these get to be a little bit of a pain in the butt. But let's say we have something like the log base 4 of 2x minus 5 minus the log base 4 of x plus 1 equals 1. So the first thing we would do is we would apply our property of logs, and we'd rewrite that as a division. So we'd rewrite it as the log base 4 of 2x minus 5 over x plus 1. So log base 4 of 2x minus 5 over x plus 1 equals 1. Now unravel the log. The 4 is the base, the 1 is the exponent. So I get 2x minus 5 over x plus 1 equals 4 to the first power, or just 4. If you cross multiply that, then you get 2x minus 5 equals 4x plus 4. And I moved things around a little bit, and may have made up a bad example here, but that's alright. You get the idea. You get 2x if you move the 2x over to the right, and then you move the 4 over to the left, you get negative 9. So x is negative 9/2. The problem with that is that if I put the negative 9/2 back in my original equation, I'm going to get the log of a negative number. You can't have a log of a negative number. So in this particular case, you'd have no solution. That gives you a general idea of, like, how to apply the properties, but you got to be careful of those ones where you have logs of negative numbers. Okay? That should give you enough information to get started on those logs and exponent worksheets. We'll work on it for a couple of days. If you have any questions, please make sure you ask.